Hello children, Manashri ma'am is back with radioactivity lesson part 2. Okay, now in this lesson we will be learning, or in this part 2 we will be learning about nuclear fission and nuclear fusion. Okay, so now let us learn first about nuclear fission. So now a nuclear fission, as the name indicates, fission means breaking. Huh? So, a nuclear fission is a process in which a heavy nucleus splits into two lighter nuclei of nearly same size when bombarded with slow neutrons. Okay, so definition says nuclear fission is the process, nuclear fission is the process in which what is happening, in which a heavy nucleus is bombarded by neutrons, then it splits up into two lighter nuclei and accompanied by a large amount of energy is released. Large amount of energy is released. So nuclear fission is the process in which a heavy nucleus, is bombarded with slow moving neutrons. What is happening? Resulting in the formation of two lighter nuclei. This heavy nucleus splits up forming two smaller nuclei. Okay, lighter nuclei. Bombarded with slow moving neutrons, and the heavy nucleus splits. Splits means breaks. Splits into two lighter nuclei of nearly same size. Along with tremendous amount of energy. Along with release of tremendous amount of energy. Now let us take an example. When a slow neutron strikes a heavy nucleus like uranium 92 235, it splits into two nuclei. It splits into two nuclei. What is that? One is it splits into barium 56 144, and the other one is krypton 3689. So the nucleus of heavy atom uranium 92 to 35, when it is bombarded by slow moving neutrons, it splits up forming these two smaller or lighter nuclei. Okay, along with it also release of 3 neutrons, plus 3 neutrons are released. Okay, then okay, 3 neutrons are released. Now this is represented chemically, or this is represented in the form of a chemical equation as represented as U 92 235 plus neutron gives or splits up to form. Actually, what happens first, it forms a unstable nucleus. 92 to 36. This is very unstable. So this splits up into barium 56 144 plus krypton 36 89 plus 3 neutrons plus energy. Okay. So other examples are, it is found that the same U9235, when it not only it decays onto these two, but also can decay into barium the 56 141 and krypton 3692, and that is like these different pairs it can split into. Hmm? It can split into different pairs of nuclei. Okay. So now in each fission reaction, the atomic number Z and mass number A remain conserved, isn't it? See, 92, 92, 235 plus 1, 236. When this splits up, 56 plus 36 is 92. 144 plus 89 plus 1 will become 236. Okay. So, is that clear? Now, now these neutrons which are formed, they again bombard the other nuclei of uranium 235 present in that uranium matter, and this fission reaction multiplies, the number of fission reactions multiply, and so a huge amount of energy is released. Okay, so this energy is called the energy released due to nuclear fission, and it is used, I'll tell you, in many other things. Okay, first let us understand, is nuclear fission reaction understood? Okay, now let me tell you controlled and uncontrolled chain reaction. So as I told you, if these three neutrons, they go and hit other uranium nuclei, and this chain reaction continues, so a chain reaction is formed. This reaction forms like a chain reaction. These three neutrons go and hit three other uranium nuclei, then again they release a large amount of energy. Each reaction is accompanied by the release of large amount of energy. So a very huge amount of energy is released when the entire uranium matter or the uranium nuclei are bombarded by the neutron, slow moving neutron. So a huge amount of energy is released in this chain reaction. So this is called uncontrolled reaction or uncontrolled chain reaction. So a nuclear bomb is based on this uncontrolled chain reaction. Now, if the same chain reaction is controlled by absorbing a few neutrons that are emitted in the fission reaction by means of using by calcium rods, then you can control the emission of energy, and that energy can be used in for many constructive purposes like producing electricity, etc. Mhm. So that is the principle used in a nuclear reactor. Okay. So first you must know controlled and uncontrolled chain reaction. So as I told you, uncontrolled is the three nuclei, which are the three neutrons which are formed by the fusion of one uranium nucleus. Go and bombard three more uranium nuclei, and this continues. At each step a large amount of energy is produced, and this keeps on continuing until all the uranium nuclei are bombarded by the neutrons. So a large amount of energy is released in this uncontrolled reaction. So this uncontrolled chain reaction, so this is called chain reaction. A chain reaction is formed. Chain means one after the other, one after the other, it keeps on happening. The three new neutrons which are formed, they hit three more nuclei of uranium, and they start again, they split up, and a large amount of energy is produced, and again three neutrons are formed, and those three neutrons further hit another three uranium nuclei, and this becomes a continuous reaction, or it is called a chain reaction, and that too uncontrolled chain reaction. So large amount of energy is used, and this energy which is released can be very harmful, and it is in the uncontrolled chain reaction, and this phenomena or this principle is used in nuclear bomb. Okay, so uncontrolled chain reaction is used in nuclear bomb. So this is used for destructive purposes. Now, if you can absorb the three neutrons formed by cadmium, by using some cadmium rod and all, then this chain reaction can be controlled. The energy released can be controlled. Then it is called controlled chain reaction. So the energy released can be controlled. So then it can be used for constructive purposes. So controlled chain reaction is one in which the neutrons released by the fission of uranium nucleus are absorbed by the cadmium rods, and then in this manner the fission reaction or the continuous chain reaction which forms of uranium nuclei can be controlled, and the energy released can be also in a controlled manner. You can control the release of energy, which can be used for constructive purposes like, and this is the principle of nuclear reactors. Okay, so controlled chain reaction is used in the nuclear reactor. Okay, now, so fission, the amount of energy that is large amount of energy that is released during a fission reaction can be used for both destructive as well as for constructive. For destructive use, the fission process is used in the nuclear bomb. Okay. Similarly, you must sometimes you have heard it as atom bomb, but the atom bomb is a destructive use. So here it is not advisable. The same way, for constructive use, the fission process is used in nuclear reactors where the release of energy is slow and controlled, and this energy is used to generate electric power. Okay, so this is how the energy released in nuclear fission can be used for both destructive as well as constructive process. Okay, So now we will learn distinction between radioactive decay and nuclear fission. Okay. Now radioactive decay is a spontaneous process, whereas nuclear fission does not occur itself. It is initiated only when neutrons are bombarded by heavy nucleus. When heavy nucleus is bombarded by neutrons or slow moving neutrons, then only nuclear fission occurs. Whereas radioactive decay is a normal process. In radioactive decay, the nucleus emits either alpha, beta, or gamma particles. Okay, and in nuclear fission, on bombardment of heavy nucleus with neutrons, a large amount of energy is released, and the nucleus splits into two new lighter nuclei. Okay, the in radioactive decay, the rate of radioactive decay cannot be controlled, whereas the rate of nuclear fission can be controlled. That is in controlled chain reaction. Okay, so is it clear? Now we will learn about the next important topic, that is nuclear fusion. Nuclear fusion is the process in which two light nuclei combine to form heavy nucleus. This is exactly the opposite of nuclear fission reaction. Okay, so now nuclear fusion. So nuclear fusion is the process in which, this is, as I told you, it is exactly opposite of fission. Nuclear fusion is the process in which two light nuclei combine to form a heavy nucleus. So, and a huge amount of energy is released. And a huge amount of energy is released. Now it is exactly opposite to fission. In fission, a heavy nucleus splits up into two light nuclei, and in fusion reaction, two light nuclei combine forming a heavy nucleus. Now, for example, but in both fission and fusion, a large amount of energy is released. Now, example, when two deuterium nuclei, that is hydrogen atom, fuse, okay, so two hydrogen atoms fuse, okay, when two deuterium nuclei fuse, a large amount of energy is released, no doubt, in both the cases, and helium isotope is formed. Okay, so this gives helium isotope. Helium 2, 3, and a neutron is also released. Neutron is released plus a large amount of energy released. Okay, so in this way, Both in the case of fission and fusion, energy released is common. Huge amount of energy is released. Uh, so, but nuclear fusion is not possible at ordinary temperature and ordinary pressure. It cannot take place at room temperature and atmospheric pressure. You have to apply high temperature and high pressure in order to in order that the reaction takes place, fusion reaction takes place. Why? Because when two nuclei come closer, because of their positive charge, they repel each other. So, to make the two repelling nuclei fuse is not easy. So, you have to maintain high pressure and high temperature to make the two nuclei fuse to form a single nucleus. Okay. So, this fusion reaction is also called thermonuclear reaction. Okay. Now, the energy released in the fusion reaction also again can be used for constructive as well as destructive purpose. In destructive purpose, this was used in the working of hydrogen bomb. In hydrogen bomb, the nuclear fusion of hydrogen atoms, isotopes of hydrogen atoms, takes place at a very high temperature and a large amount of energy is released by the bombardment of the uh, these new hydrogen by the bombardment of these helium nucleus. So these form in the process four hydrogen nuclei fuse to form a human nucleus with a release of lot amount of energy. Okay, so this is also a continuous reaction happens, a chain reaction happens. A large amount of energy gets on added. So first two hydrogen atoms combine, then four hydrogen atoms combine, then eight combine, and so on. So every time a large amount of energy is released, and that energy can be used for both constructive as well as for destructive purpose. In case of destructive purpose, it was used in the making of hydrogen bomb. Okay, so now differences between fusion and fission reaction. Okay, in fission, when neutrons bombard a heavy nucleus, it splits into two nearly lighter nuclei. In fusion, at very high temperature and pressure, two light nuclei combine to form a heavy nucleus. This nuclear fission reaction is possible at ordinary temperature and pressure, whereas nuclear fusion reaction is not possible at ordinary temperature and pressure, but is possible only at a very high temperature and a very high pressure. Okay, now more energy is released in nuclear fission reaction than in nuclear fusion reaction. In nuclear fission, the fissionable substance, that is the substance that undergoes fission, is a radioactive substance. In nuclear fusion, the fusionable substance, that is the atoms which are fusing, are not radioactive. Okay, so it does not give out any harmful radiations, and disposal of its waste is also not difficult. So these are some points of difference between nuclear fission and nuclear fusion. Okay. That completes this chapter, radioactivity. Thank you, children, for watching. Take care. God bless you.